This is lesson 10.2. First two, we all should have known how to do the first two. It's just asking us to find the circumference. Which, if I'm given my radius, then I just do my 2 pi r formula. All right, for that one, folks, I got 182.2 centimeters. If I'm given the diameter, like I am in number 2, then I use my pi times the diameter formula. These formulas mean the same thing, so you could have used either or. And for that one, I got 51.8 meters. Okay, 3 and 4 were kind of a fun little challenge because we haven't technically talked about area of a circle, but based on your previous math knowledge, who knows the formula for the area of a circle?
2 pi r. No, pi r squared.
Pi r squared. Good. Pi r squared. And remember, area, we're essentially calculating like this space. Circumference is the distance around the outside. 2 different things, right? Area versus circumference. So, 3 and 4 involved area. And we didn't do area in 10.1, but let's see if you got these right. Did everybody get a chance to try them? Because we're awful chatty, so I just assume you're done. I feel like I'm like a rosy brush. All right. So, on number 3, it says, find the diameter of a circle with an area of 153.94 square feet. All right, so Lauren told us area is pi r squared. Here's what we know. We know the area is 153.94. So if I were to plug that into my area formula, do you see how I really have an equation here with my unknown being the radius? So think of this how you'd solve a normal equation. You're just going to take the layers off around r. How can I get rid of timesing by pi? Divide by pi. We got to get rid of this first before the square root. Divide by pi. Divide by pi. That's going to give you a pretty wonky decimal. I'm just going to round it to, it was about like 49. It was like 49.00, something like that. So I know my radius squared is about 49. Now that we have that layer taken off, now we can get rid of the squaring by doing what, Alejandro? Square root. And I get about 7. Now, they asked me for the diameter, not the radius. How to find diameter? Just double it. Yep, the diameter is 2 times the radius. So here the diameter would be 14 units. Feet, since the area was feet squared. Anybody get that one right? Okay. 4 was similar but different information here. This time they want us to find the area and they gave us the circumference. So think about it. In my area formula, all I really need to know is what the radius is to calculate the area. So which circumference formula allows me to solve for radius? The one that's 2 pi r. You could use pi d, but then you're going to create an extra step for yourself, or you have to divide that by 2 to find the radius. So here, now we know the circumference is 28.27. So if I plug that into my circumference formula, now this is an equation where I could solve for r. How would I do that algebraically? Ideas? Divide by 2. What else could I divide by?
Pi.
Divide by 2 pi. All right, now I'm going to warn you. This is important. You have to be careful with how you type this in your calculator. You have to wrap this in parentheses, because if you don't, this is what your calculator will do. If you typed it in like this, your calculator doesn't do order of operations unless you like notate it with parentheses. So your calculator is going to do 28.27 divided by 2, get that number, and then it's going to times it by pi. That's not the math we're doing here, right? We're dividing this number by 2 times pi. All right, so all you need to do in your calculator is wrap that in parentheses so your calculator knows to do this first, and then take this divided by that product. Okay, so you got to be careful with that. Or you could do what Siler said if you wanted to divide by 2 first. get that number, and then you have pi r, then divide by pi. You could do that as well. Here's the number you should be getting. I'm just going to round it to 4.5. I'm not done. They asked me for the area, which is pi times the radius squared. So for that, I got about 63.6 yards squared. Anybody get that one? Nice, guys. All right. Today we're talking about angles in our circle and something called arcs. First, we'll start with angles. Okay, so if I were to draw radii in my circle, do you see how we could form some angles like angle 2 or angle 3 or angle 1? These angles have to total up to 360 degrees inside of our circle. Think about like anytime you like rotate in a circle, a lot of times they say you've made a 360 all the way around, 360 degrees. So the central angles, central meaning formed with the center. So like this angle's formed with the center. This angle's formed with the center. They always have to add up to 360. Okay. So looking at an example of this, I like this problem. Here they're giving me a bunch of angle measures that are formed by these radii, a bunch of central angles. So your first instinct might be to total all these up and set them equal to 360. But do we know what this angle is? We don't. Doesn't give me a number, doesn't give me an expression. If it did, this would be a really easy problem. Add these all up, total them to 360. Other ideas? Lillian?
Maybe add up what we know and then plus x equals 360. Or not x, but like
a different variable?
Yeah.
I like that idea, but then we have one equation and two variables. We can't solve that. Good thinking. Other ideas? If we had two equations and two variables, we could solve that. I don't know another way that relates. Yes, idea.
The half that we do know equal 180.
Okay, well, if the whole circle is 360, you guys agree that half of it, and think this forms a straight angle. Straight angle has a measure of 180. Good, let's try that. And then we can find x. So this angle plus this angle plus this angle, those must be 180. All right, those x's add up to 26. Constants add up to -2. So let's solve this really quick. We get x to be 7. All right, follow-up question says, all right, if you know what x is, now find the measure of angle RTS. So remember how we notate M means measure? Notate angles. The middle numbers are vertex or angle. So we're talking about this angle, so we just do 8 times x, which now we know is 7. 8 times 7 is 56, minus 4. The measure of angle RTS would be 52 degrees. Oops. Sorry. Must have accidentally hit that. All right, last one for this. VTU. VTU. This one is 5 times x, which is 7 plus 5. 35 times 7. No, 35 plus 5 is 40. Okay, so we need to know all the angles add up to 360. And yes, half of the circle. What do we call halves of circles? You guys know? Semicircles. Good, that's what we're going to talk about next. Add up to 180. Okay. Arcs. Arc is basically just like a piece of your circumference, kind of. And it's formed by like a central angle intersecting the circumference of our circle. So if I had this central angle right here, it would intersect my circle at these 2 points, and it kind of cuts my circle into 2 pieces. This piece, that's an arc, and we could also classify this piece, as a different arc. Those are both examples of arcs. All right, so how we differentiate between the two is basically if the arc is less than halfway around the circle or greater than halfway around my circle. Let's actually start down here if it's exactly halfway around my circle. So looking at this arc that's formed by this straight angle, which we said that's a semicircle. Semi means half. The measure of this arc is equal to the measure of the angle it forms. So when we are measuring arcs, think of this as you're almost like lining this up with a protractor and these 2 endpoints. You're trying to measure what angle that's forming. All right, so if it is halfway through our circle, the measure of that arc would be exactly 180 degrees. Here's how we notate arcs. Well, measure is just M. This arc, you classify it by its endpoints, but you have to be careful. So if I just said AB, I wouldn't know if you're talking about this arc or AB, this arc. Now here in a semicircle, it doesn't really matter because they both equal the same measure. But if I want to talk about this piece, I'm going to use point D, and I want to do it in that order that I'm rotating around my circle, A, D, B. Measure of arc A, D, B, and here's your marking, like an arc. Not a straight line, like an arch. The measure of that arc would be 180 degrees. I'm not talking about the length of that arc. We'll get to that at the end of the lesson today. I'm talking this arc forms what angle. Okay? All right, that's a semicircle. If the arc forms an angle less than 180 degrees, like this one, we all agree that this angle right here would be less than 180 degrees, we call those minor arcs. All right, so the measure of that arc, I'm just going to call that arc AB, would be whatever x is, that acute, I shouldn't call it acute angle, that angle that's less than 180, which is the same as the measure of this angle, ACB. All right, if the arc formed, like this one right here, is bigger than 180 degrees, which we haven't really looked at angles bigger than 180 degrees. So we worked a lot with like triangles. We did a little bit of like exterior angles that had bigger degree measures, but in circles, we can definitely have angles larger than 180 degrees, like this one, 180 plus a little more. If this arc is forming an angle measure
First in baseball can be released too. Get ready and load the bus. Thank you.
bigger than 180, we call it a major arc. So the measure of this arc, I'm going to call it ADB, is just going to be 360 minus whatever x is. Okay, so a little vocab for you, and we'll do some practice problems here. But I want to be upfront right away, because this is usually confusing. If I ask you to find the measure of an arc, that's different than if I ask you to find the length of an arc. When we're talking about measure, we're trying to figure out what angle it forms. We're talking about length, we're talking about the distance. So I measure that in like inches or centimeters. A piece of a circumference, essentially. All right, let's try one. So this says WC is a radius of circle C. Identify each arc as major arc, minor arc, or semicircle, then find its measure. Okay, so this is saying the measure of arc X, Z, Y. So that means we're going to start on X, and we go towards Z, and then finish at Y. We're talking about this arc. Major, minor, or semicircle? Semicircle. So the measure of this arc would be how many degrees? What angle is that forming? What would this angle be right here? 180. Yep. The measure of that arc is 180. It helps if you like trace the arc with your pencil. All right, B. Arc. Whoa. Get back here. Arc W, and I need to go to Z next. And then finish at X. I gotta go this way. See that? If it was this, that'd be that arc. That's something different. You gotta go in that order. Pay attention. Notation is important. W to Z, finish on X. Major, minor, semicircle. Major, big. Think like the major leagues in baseball. Bigger than the minor leagues. Major arc. What's the measure of that arc? 270. How'd you get that number?
It's 3/4 of 360 degrees. That's 270.
Okay, you could do it that way. You could do 360 minus 90, or we know this is 180 plus another 90. 270. Everybody with me? Okay, guys, it's Friday, 8th hour. Get excited.
Friday, 8 hours exactly the time.
We're all still weekend. We're nearing the finish line of this week. All right, measure of arc X. X, finish at W. Major, minor, semicircle.
Minor.
Is that you? Thanks, Marilyn. Minor arc. What's the measure of that arc? 90 degrees. Okay, fine. I'll let you guys try the next one. Share some of the fun.
Okay.
A and B. Oh, just kidding. These aren't lettered. Find the measure of those specified arcs. I'm going to give you like 1 minute. What are we thinking for the first one? 90 degrees? That's what so I saw on text paper. 90 degrees. Good job. What about this one? I got 148. 148. All right, let's look at this. I, J, K. This, I think, is 58, right?
Yeah, oh yeah. That's
58 plus this. This is this whole arc. 148.
Oh.
Would this be a major, minor, or semicircle?
Minor.
Minor, less than 180. Okay. This next one's kind of fun. This time we're given like the percentage of the circle it takes up. Okay. Now, looking at circle graphs or pie charts, these percentages total how many percent? 100, right? So they want us to find what angle, essentially like 37% of your circle would form what angle. Okay? If we were to look for the mountain portion. This one says KL. KL. So we need to figure out 21% of 100% is equivalent to what portion of 360 degrees. So we're going to set up a proportion. If you've heard of the percent equation, my last hour didn't know this. If you've heard of like percent over 100 equals is over of, have you ever heard of that? Anybody? You don't really need to know this to set up the proportion. So here's how we're going to set up a proportion. We're going to set up a ratio of the percentage. So I know 21% out of my 100%. I know that fraction. I want to figure out when that's proportional to how many degrees out of my total 360. Okay, so see how I put basically the portion of my circle up top and the total of my circle on bottom. This is the percent piece. This is the degree piece. With me? Okay, or you can do 21% of 100 is what of 360 degrees if you want to use that little equation. How do we solve proportions? Cross, multiply. $75.6 degrees would be the measure of this arc or that angle. I want to think of it. Okay, let's try another one. What about arc NJ finish at L? Woofda. NJL. What percent of my chart is that? It is 84. How'd you do that, Tyson? Did you add them all or did you add them all? That's how I did it too. You could also do 100 minus 16, yeah. If you wanted to. So 84 out of 100% is what portion of 360 degrees? That's what we're trying to figure out. Proportional reasoning, my friends. Very important. Cross multiply. Come over here. Divide by 100, aka move my decimal. 2. Does that answer make sense? That 84% of my circle would be about 302 degrees? Yeah, it's a large portion of my circle, right? Obviously, the whole thing's 360. Okay, now we're going to get into arc length, which again is different than the measures of the arcs. Measures, your answer should have degree units. You know I'm thinking about those units. Measure should have degrees. Length should be measured somehow in terms of like distance, whether it's inches, centimeters. Now we're measuring length. Okay, so essentially we're going to set up a proportion just like we were doing with those percent ones. So if I want to find the length of an arc, which they often notate it as a lowercase cursive L, they're referring to the length of that piece of your entire circumference. So it's equal or proportional to the ratio of whatever degree this is of your entire circle. Okay? So this time for my first ratio, I want to know the piece of my arc length. I'm going to write it as a ratio to the entire circumference, which I'm going to use 2 pi r. So the fraction of that length is proportional to this angle. They just use x for the central angle of the total angle 360 degrees. That's essentially like the equation you're going to use for these. When you get to algebra 2, actually, I don't think you do it till pre-calculus. There's kind of a formula you can use for arc length. But you have to learn something different about the angles. So for now, you guys can just proportional reason your way through it. If you don't want to memorize that equation, just think of it as a ratio and set up your proportion. All right, let's try this problem. So this one says, if the measure of the length of the arc of a circle is 113.6 inches, and the radius of the circle is 31, find the measure of the angle it would form. Okay, so here's what we need to do. That arc length, I'll plug that number in a second. That ratio to my entire circumference is equal or proportional to what portion of the whole 360 degrees of my circle? Here's what we know. We actually know the length of the arc, that's L, is 113.6. Do we know the radius? Radius is 31, so I can essentially figure out this circumference. We'll do that in a minute. I'm trying to figure out what angle that forms. Central angle is X. Okay, we're still going to cross multiply. So here I'm going to keep this exact, meaning I'm going to do 2 times 31 times pi. I'm going to write that as 62 pi x. 62 pi times x equals this times this is this number. How would I solve for x? Alejandro?
Divide the bigger number by 62.
Good. Divide both sides by 62 pi. Don't forget to put parentheses in your calculator. Rounded to the nearest degree, I got 210 degrees. So folks, just to give you a little visual of what we just found, you are given an arc length. Let me try to make this kind of legit. You're given, hey, this arc length, we calculated like what fraction that is of your entire circumference, that's what we did here, to figure out what fraction of 360 degrees that angle would form. And we got 210, because those are proportional. Make sense? It's good to understand and not just memorize the formulas. Let's try another one. Sorry, are you done? Yeah, okay. Notice the difference here. It doesn't say find the measure of arc AB. It says find the length of arc AB. I want to know this distance. It's not 125 degrees. That's the measure. All right. Here's my little proportion. This time I don't know the length. That's what I'm trying to find. I can figure out the circumference because I know the radius is 10. And I know what angle it forms. 125 degrees. All right, here's how I'd solve this. Cross multiply. So I'm going to do this first. 360L. Try to make your L's lowercase cursive, just to be picky. Just to be precise, I should say, not picky. Here, again, we're going to do this exact. So I'm going to do 2 times 10 times 125. That's 360. 360 pi. No, sorry, that's not 360. 2,500. Sorry, looked at the wrong answer. Leave it exact, though. 2,500 pi. Okay, how would I solve for L? Divide by 360. Now, everybody get out your calculators and do this with me. This is how I want you to type it in your calculator because we're going to get an exact answer and we're going to get an approximation. So exact means we need to leave it in terms of pi. So essentially, we're just going to simplify this fraction. Okay? You could do this a couple ways in your calculator. You could do, let's try this. I didn't try this last hour. If you use the fraction button, will it simplify this fraction? All right, it's going to give you a mixed number. You could also, what I did last hour was I had them like actually divide this, which you can do it this way, but then you just have to change it to a fraction. Either way, you're going to get this mixed number. If you want to practice your third grade math skills and convert it to an improper fraction, you can, or you can use this button. Second fraction changes it to an improper fraction. I think I showed you that before. So this, or, practice your mental math and just reduce that in your head if you want to. I'm not really assessing you on your fraction skills. I mean, yes, it's important, but now we're trying to learn geometry. So that fraction reduces to 125 over 18. So we have that times pi. Now, when we have fractions times pi, we usually write the pi up here. Okay? Because pi as a fraction is pi over 1. So if you times that to a fraction, you just multiply it up top. 18 times 1 is just 18. There's the exact number for arc length, the exact distance. To get a decimal, you just take that fraction times pi. Boom. We'll round it to 21.8. I'm talking about length, so my units inches, since that's what my radius was measured in. Okay, see the difference? That's length. Oh, I got my 10 moments. Let's try this one. Find the length of arc ACB. ACB is this one. ACB is this one. So before I do any calculations, my number should be bigger than this, right? Should be bigger than that length of that little arc. All right, so L over 2 pi r equals x over 360. My radius didn't change. What angle would that arc form? 360 minus 125. 235. Do that in your head?
Yeah.
Nice. 235. Cross multiply. 360 times L. 2 times 10 times 235. 4,700 pi. Leave it exact. Don't use the pi button until the very end. Divide by 360. Okay, we're going to try this. I want you to reduce this fraction. If you want to do it in your head, you can. Or you can do it in your calculator. Improper fraction. Who's got it? Tyson?
235 over 18.
That's what I got too. 235 over 18. Pi goes up here. All right, everybody times that by pi. You should get about 41. Answer makes sense. We knew it had to be bigger than this arc length. If you wanted to add those together, it should equal your whole circumference. If you wanted to be a stellar math student and check your answer. All right, folks, you're going to try the next one while I pass out the worksheet. And then we'll wrap it up with the final problem. You try this one. I want you to find the length of arc DA. Try it. Exact and decimal, please. I'm just taking off your desk, sorry. You get kind of a cool answer for this one. All right, DA is this one, this little guy. My radius is 4.5. My My angle is 40. 2 times 4.5 times 40. 360 pi. What's 360 divided by 360? 1 pi. That length is exactly pi, which is about 3.14 centimeters. Okay. Final problem to just wrap up this lesson in a nice pretty bow. Find the length of arc AD, this distance. This picture is kind of confusing. This radius is 12. It's very unclear if they're labeling the radius or the diameter. It's the radius. I had to look it up. All right, let's do this one more time. L over 2 pi times 12. Ooh, what angle does that arc form? How'd you get that, Malin? You're right, 152. Good job. 180. Did you do that in your head?
Yeah.
Awesome sauce. 152. Okay. 152 times 2 times 12 was 3,648 pi. Divide by 360. I got that fraction to reduce to 152 over 15 pi. As a decimal, 31.8 centimeters. Okay. The next one we can all answer in 10 seconds. What's the measure of arc AD? 152 what? The measure of arc AD, that's different than the length. The measure that arc forms, 152 degrees. Those are the two concepts we learned today. There's the difference. Oh, we finished with 3 minutes to spare. I told you guys that was fun.
Oh.